Assalamu alaikum. My name is Hanan Ahmad and my registration number is 21TE25. Today we are going to discuss lab number 7 of digital signal processing of the title Frequency Analysis of Digital Sequences. So the main lab objective for this lab is study digital sequences in terms of frequency spectrum, and the second one is contribution of high frequencies in a sequence, and the third one is contribution of low frequencies in a sequence. Now let's move towards task number 1. Task number 1 is consider the following sequence. Number of signal is given x of array. We have to plot the signal where sampling frequency is 20 kilohertz, and the main task is redraw the sequence after removing frequencies above 5 kilohertz. Observe and discuss the effects of this removal of frequencies. And the second question is redraw the sequence after removing frequencies above 7 kilohertz. Observe, discuss the effects of this removal frequencies. Now let's move towards the MATLAB to simulate this code. So first of all, we have given sample x and the given sampling frequency, that is 20 kilohertz. We use the formula of time vector, and then use plot command, and then labeling this plot. By on x-axis we have time and on y-axis we have amplitude, while the title of this graph will be original signal. As cutoff frequency will be 5000. For second part, as we can see, we have to find graph of values less than 5 kilohertz. So the cutoff frequency is 5000. So we have normalized the cutoff frequency by using the formula, and then we have design a low pass filter. After this we apply the filter of the above signal and then use plot command, and we label the x-axis of these plot as time and y-axis as amplitude, and title these plot as signal with frequencies less than 5 kilohertz. Let's move towards part 3. In this we have cutoff frequency, that is 7 kilohertz. Then we normalize the cutoff frequency, then design a low pass filter, then apply the filter to the signal, then use plot command, and saying x-axis as time and y as amplitude, and title these plot as signal with frequencies less than 7 kilohertz. When we simulate this code, we obtain three figures. The first one will be original signal, as we can see, and the second one is the frequencies less than 5 kilohertz, and the third part is frequencies less than 7 kilohertz. Now let's move towards task number 2. In this task we have given an audio signal, so we have to find DFT of the signal, and the second part will be remove the upper half of the frequencies, and the third part will be remove the lower half of the frequencies. So let's move toward MATLAB. First of all, we define the path of this audio signal, then use calculate DFT using FFT command. After this we obtain the frequency axis where n is equal to length of y, and then frequency axis. To plot this spectrum we use plot command, and then label this graph as x. On x-axis frequency is present and on y-axis there will be magnitude, and the title for this graph will be DFT of audio sequence. When we simulate this code, we obtain a graph as well as an audio signal by removing the frequencies. As we can see, a frequency of a normal audio signal we can listen, and this graph will be obtained. So let's move towards task number 2. In part 2, we have to find the DFT by removing the upper half of the frequencies. So let's see this code. First of all, we define the path of the music signal, that is our audio signal, and then describes the index corresponding to fs over 4. That is, index is equal to round into n by 4, where n is the number of samples. Then we have to zero out the upper half of the DFT coefficients. We give zero value that is present on the upper half of the DFT coefficients, and then reconstruct the audio sequence by using inverse DFT, and then play the modified audio. When we simulate this code, we will get the sound of the lower half values. As in this task, we receive the signal with frequencies less than of the DFT coefficients. Now let's move towards part 3. In the third part, we have to remove the lower half of the frequencies. So let's move toward MATLAB. First of all, we assign the path of this audio signal, then apply DFT using FFT command, and then obtain the frequency axis for plotting, and then let give the zero value to the lower half of the DFT coefficients, and at last we reconstruct the audio sequence using the inverse DFT. So let's simulate this code. As we can see in this audio signal, we remove the lower half of the DFT coefficients.